Okay, we're recording, so go ahead, take it away.
Okay, thanks a lot, Ken. So first of all, very good afternoon to everybody. I think all of you are in the US, so it's around noon for you. And thanks to Ken for giving me this wonderful opportunity. So this talk, or rather I would say discussion, is based on a paper that we got published in JCS, Journal of Consciousness Studies, a few years back. So I'm going to come to the actual result that we published in the paper and the idea a little later. What I would like to really focus on for most of this session is the motivation behind the idea. And the primary reason is that the particular paper that we published is like a milestone along the way, but there is still a very long way to go. So my objective of taking your time today is not so much to impress you with the result that we found, but with the direction that I wish to take, because it's as I mentioned, there's a long way to go, and I would like to have more collaborators who can help me along the way, so that we can further strengthen the result that we have found and make it more concrete and find better evidence for some of our ideas. So with that, I would like to start with sort of a background of myself, not really a CV kind of a thing, but something that is relevant to this idea. My educational university degrees, both my bachelor's and my PhD degrees, have been in electrical engineering. But my primary interest has always been in physics. But interestingly, I have never published a paper with a physicist. Most of my papers have been written with mathematicians, but I've never really proven a mathematical theorem, and that was something that was always on my mind. That can I also prove some substantial mathematical theorem and get it published in a mathematical journal. So once I was having a discussion with a mathematician collaborator of mine, who is a senior prof at the Imperial College London, and I asked him, how do I learn to prove theorems? I have done a lot of computer simulations, I've done a lot of mathematical modeling and stuff like that, but I've never proven a theorem. So how do I go about proving a theorem? So he asked me a question that got me thinking a lot is, what do you wish to prove? Learning to prove a theorem is fine, but unless you have a desire to actually prove something concrete, you won't really learn how to prove something. So that got me really thinking, that okay, if I want to learn to prove theorems, I need something concrete about what do I wish to prove, and then I can go about finding out how to proving that. So that brought me to this central core idea, which is sort of has been the basis of my work in the field of consciousness, which is this concept of five koshas or sheets. This comes from the Indian approach to consciousness, where it is sort of believed that the human system is divided into five sheets, so to say. So the physical sheath that we all experience as the body, that is called the Annamaya Kosha, which is the physical sheath. Then we have what is called the Pranamaya Kosha, the energy body. Then we have the Manomaya Kosha, which is the emotional body. Then we have the wisdom body, which is called the Vijnanamaya Kosha. And then we have the bliss body, which is the Anandamaya Kosha. So now these terminologies are not so important for our discussion, but what is important is that according to this particular perspective, there is only one aspect of our human existence which is measurable, which is the physical body, and the remaining four aspects, it doesn't matter what they are, it doesn't matter what names we give to those aspects, but the remaining aspects of our being, they are not measurable but still equally real. And this particular perspective sort of says that there is a exchange of energy, exchange of information, exchange of memories between these different sheets, so to say. So whatever, let's say, I am experiencing right now, by talking to you, the sensors are acquiring some information through various means, sending to my brain, and by some means which we are currently not aware of, by some means that information, at least some part of it, is also going into these non-measurable aspects of reality. So when I was thinking about this question about what do I want to prove, and at the same time I sort of came across this model, so to say, of a human system, that gave me a very strong sort of idea that there must be violation of energy conservation in physical systems, and this was the motivation behind the whole idea, which finally led to the JCS paper, where we were able to come up with a mathematical set of steps to lead to that conclusion. But this was the core idea, that our being as a human system is divided into these different layers, and it's only one layer which is measurable, which leads to which where all the laws of physics are applicable. But there are a lot of these other layers which are inherently not measurable, but they are so much real, and there is an exchange of energy that they have with the physical system. So there must be a violation of energy conservation, and that got me started towards this path of finding evidence and maybe even a mathematical theorem to prove that that conscious systems cannot be described by pure physics. There must be something more than pure physics if we really want to explain how these conscious systems behave. So basically, if we think about it from a slightly more, more commonly known perspective, so we have basically two realms. One is the objective reality, which is governed by physical laws, mass, charge, and all of its stuff, which is explained by a third person perspective, which we call objective science. We make theories, we make measurements, we come up with predictions which are tested in a lab. But there is also the subjective experience, which is a realm of, qualia, where we ask what is to be like to be something. That you may say that, the color red has a certain frequency, and because of which we are experiencing red. But that doesn't explain what it is like to be red. And this is what was coined by Chalmers, as all of you know, as a hard problem, is that why is physical processing accompanied by subjective experience at all? And this is, I guess, the problem that all of us in this group are trying to solve. And Levin came up with this core insight that no objective physical description, no matter how complex, can really explain why neuron firing feels like pain. So you may come up with neural correlates of consciousness. You may say that if I switch off this neuron, you won't have this experience. If I switch on that neuron, you will have this experience. That tells us about which physical processes may lead to what kind of experiences, but that still doesn't explain that why is any physical process accompanied or related to any kind of a subjective experience. So that is a gap that one has to fill if we really want to solve the hard problem of consciousness. So as I mentioned, most of what neuroscience is doing is that they are studying the neural correlates of consciousness. But it is very important to understand and accept that correlation is not identity. You may find a pattern that correlates with redness, but that doesn't explain why it feels red. That is the explanatory gap all over again. That just finding something that may correlate with an experience doesn't really explain the basis for that experience itself. And we cannot be sure if the correlate is sufficient for the experience. There may be that particular correlate that we found which leads to that experience may actually just be a small part of a wider non-physical process that we don't even have access to. And we have birds, other animals who have similar experiences. We could believe that because they are again biological systems who have similar senses, and it is quite likely that the neuronal system that they have is following a very different kind of a pattern which leads to the same experience. So even if we find such neural correlates of consciousness for certain experiences, those correlates are neither necessary nor sufficient. That's a key point, that we need to understand that even if you find an NCC of the self, it will always remain a correlate and not the self itself. And even then, it is neither sufficient nor necessary, which is a major limitation in this approach to understanding consciousness. So the basic question that we ask is, do conscious macrostates even supervene on physical microstates? So physics and the physical way of thinking assumes this. This is their default assumption that anything that happens in the universe must supervene on physical, microstates. But we question this assumption, and in our paper, we actually show that this is not true. That we show under some special conditions that conscious microstates, they do not supervene on physical microstates, which leads us to this conclusion that there must be some kind of violation of energy conservation happening in these biological systems. So the deduction that we arrive from here is that if we say that a conscious macrostate does not supervene on physical microstates, then that leads us to this fundamental deduction that consciousness is not some kind of an emergent property of physical systems, but it is actually a fundamental property of the universe. So physicalism's core tenet is that that there is psychophysical supervenience, which means that it's a belief, that the mental facts are wholly determined by physical facts. And if two worlds are physically identical, they must be mentally identical. This is an assumption of physicalism, but we show this assumption to be incorrect in our paper under special circumstances, of course. It's not a general enough proof right now. We are working towards that, but at least we have made some progress by showing that under some special circumstances, this assumption of physics, does not, really hold. So the idea is that if consciousness is not reducible to, and not determined by the physical, then it must be an independent, non-physical, and fundamental property of the universe, just as we have space-time, mass, charge, and other such, fundamental properties. So this is the basic idea that we, try to emphasize on in our paper. So one of the consequences of our work is that we challenge the causal closure of the physical. This is again another assumption of physical science, I must say, that physical science again assumes that all causes that lead to physical phenomena are again a part of the physical world itself. There is nothing outside the physical world which can influence what goes on in the physical world. It is important to understand that this is again an assumption of physics which works well in many situations, but not so in the case of biology. And this idea of interactionism, which I mentioned, which is the interaction between the physical sheath, the physical body, and the other aspects of human system, which are non-measurable. That interactionism is a direct challenge to the CCP, which is a core belief of physical science. And this is not something that we are like the only ones saying such things. This has been proposed earlier also. So if we look at Robert Rosen's MR systems, which are actually quite popular in the study of theoretical biology. So he came up with a system which M stands for metabolism, R stands for repair, and you show that if you model biological systems in this manner, then it follows that living systems are not simple mechanisms. That if you study their organizational self-referential closure, it means that a living system cannot be fully reduced to its physical parts. I'm not going to go into details of what a MR system says, but I would, if you're interested, I would strongly, recommend you to look into this. This is a very popular framework, and this very strongly emphasizes on a lot of the ideas that we are actually, trying to say in our work, and the direction that we wish to take. So here it is very important to clarify that when we talk about violation of energy conservation in physical systems, we are not really saying that we are not really trying to invent some new science. We are not trying to say that sort of science is wrong, or physics is wrong. That may be an impression that may get created. So all that we are saying is that physics works in most situations where it has been tested, but there are situations, especially when we are dealing with biological systems, where we have the property of consciousness. In those systems, some of these ideas, which are very dear to physics, they do not really work and they do not really hold, and that is something that needs to be, tested. So physics is still fine for most of the universe, but when it comes to biological systems, there are very strong reasons to believe that some of these laws of physics can actually be bent. And it is also important to remember that even within physics, even if you take the framework of physics, the law of conservation of energy is not something which is really absolute. So if you look at the kind of Noether's theorem, it says that energy is conserved only in systems which have time translation symmetry. So this is something important, and where the system's laws of motion are derivable from a Lagrangian via the principle of least action. So this is a fairly restricted kind of a setting where law of conservation of energy is defined. But if you have a system that doesn't really follow these requirements, then in those systems, conservation of energy can be violated. And our thesis, or rather a result of our work, is that biological systems fall in this category. So we show in our paper that a biological system which is conscious cannot be modeled as a Hamiltonian, which then naturally implies that the Noether's theorem does not apply to that system, in which case conservation of energy can very well be violated. If anybody wants to interrupt me at any point of time to either add something or suggest some ideas, please feel free to do that. The idea is to have a discussion and not just me talking all the time.
I'd like to remark that physicists can write Lagrangians for biological systems, but it's a comedy. A famous opening phrase goes, "Consider a spherical cow."
Yeah, true, very true. Yes, absolutely.
I have
Yeah.
done that trying to analyze electromagnetic effects and how much they might raise the temperature of a living organism. So the living organism becomes a spherical bag of salt water. That's it.
Very true, very true. Thank you. And this idea of violation of energy conservation also has some precedents even in mainstream physics. For example, if you look at general relativity, then we know that the entire space-time itself is changing, universe is expanding. So there is no time translation symmetry at the global level. Although this does not necessarily apply to conscious systems, but the idea that I'm trying to convey is that. Energy conservation, which was like a rock solid principle when it comes to classical mechanics, is no longer on such a strong footing when it comes to modern physics in both the quantum and the the kind of relativity domain. And when photons they traverse space, they move through regions of varying gravity. Their energy also changes, and this energy simply vanishes into the underlying space-time geometry or something like that. So we have some ideas which again hint towards non-conservation of energy in relativity. In quantum mechanics, we have energy-time uncertainty relation. Of course, somebody can say that whatever energy is lost in a period can be gained in some other period. which is fine. But the idea is that, again, that there can be very short durations of time where energy conservation can be violated. So the idea that I'm trying to convey is that something that was very sacrosanct in the Newtonian regime is no longer so sacred now when it comes to modern physics. And perhaps we need to be open to the possibility that conscious systems are another domain where some of these cherished principles of physics may no longer apply. So
I
now the
would,
question is, huh,
can I point out that quantum theory does not itself satisfy causal closure of the physical because of the measurement problem.
right. That is exactly what I
There is
mentioned.
no specification in
Yes,
quantum theory about when an operator is applied or which operator applies.
yes,
And so therefore it's not causally closed because those actually have physical effects.
yes,
When to measure
absolutely.
has a physical effect, or what to measure. So I can measure, if I measure position, I get a different physical state than if I measure momentum. And there is nothing in quantum physics that specifies which to measure or whether
Yes.
to measure them at all. And if I don't measure them at all, then I get the interference pattern when I do finally measure them. And so therefore physics as we currently have it is not causally closed.
Yes, and the hope was that this issue with physics would lead to us better understand how consciousness works, but unfortunately that has not happened so far. But my hope is that the deeper analysis of the measurement phenomena will lead us to a better understanding of how consciousness works. So interestingly, because you mentioned it, I would just want to mention that I'm working with somebody, from the University of Colorado to analyze these MR systems in slightly more detail from the quantum measurement perspective and see if we can bring those ideas together. Hopefully, in a year or so, we'll have something to share in that regard.
Are you
So
aware
now,
of Henry Stapp's work? He thinks that
yes,
the measurement problem is where consciousness affects. So that's the free will, where consciousness
yes,
affects the
yes,
evolution of the physical world. And
yes, yes,
so, I mean, he hasn't specified it in enough detail to have a model of the neuroscience of how we actually make decisions. But I think it's intriguing because he's not necessarily he doesn't argue for violation of conservation of energy. Although I think if you took his if you applied I think if you applied his approach with the quantum Zeno effect, you might end up with violations of violations of conservation of energy, because
right,
the repeated application could hold the state in place in a way that would violate conservation of energy. But everything that his theory is completely consistent with existing quantum mechanics. It just supplies a mechanism, the purported mechanism for when a reduction, collapse occurs is consciousness. But I think that could well fit into your theory.
right. I'll look into it definitely. Thanks for that. Thank you. So now we mentioned that the physical realm is different from the consciousness realm, and conscious macrostates do not supervene on physical microstates. So then, what do we say about the nature of this independent so-called field of consciousness? So one option is somebody could say that each particle has its own consciousness, like it has a charge or a mass or something, and there are some theories that claim to say that. But an objection to this idea could be that whenever we as human beings experience consciousness, it is of course an inherently subjective property, and more importantly, it has so far been reported only in certain complex biological systems. If it was a property of every single particle, then we would see it in some other sort of inanimate objects also, which we don't. And more importantly, the experience of consciousness in living beings has always been unified. When I experience consciousness, I don't experience consciousness in parts. I don't see myself as consciousness of my hand, consciousness of my leg. I don't experience that. I always experience consciousness as a one unified thing. So that is the objection that one can have to this idea of every particle having its own consciousness. The other idea could be that there are something called individuals, like the idea of a soul, which is popular in almost all religions, that each individual has its own consciousness. We have, like 7, 8 people in this, call. So each of us has their own, sort of field of consciousness, which binds to the body and leaves the body at the time of death. That is something that I was not sure of earlier, but when Ken invited me to give this talk, I started reading a lot about that possibility, and then I sort of came across some very interesting papers in the field of anesthesia, which I had also shared with Ken. Where interestingly, what I found out is that when people experience anesthesia, it's a complete blackout experience. No, it is not like sleep. When I sleep for 8 hours, when I wake up, I know that I had very good sleep. I was there during sleep. I have some kind of a proto consciousness, kind of an experience. But anesthesia, on the other hand, is a complete blackout experience. It is like you just were not there during that time. It's like you are just gone. So that's, an objection to this idea of an individual sort of consciousness. Again, these are not proofs. These are just objections which are, open to debate. The third option, which is that there is a unified field of consciousness. So this is, again, as I said, this is not a proof or anything, but this is something that, currently I'm gravitated towards. And this is also something that is aligned with the idea of consciousness if you study from the Indian scriptures perspective. So the Indian view of consciousness also talks about the idea of an individual consciousness, but that is not something which is emphasized on, that much. What is emphasized on is really this idea of a unified field of, consciousness. Yes, Catherine.
Yeah, I wonder. That's an interesting, and I've read lots of claims of back and forth between individual consciousness and unified field. But if it's a unified field of consciousness, why do I feel like I'm separate from you and I can't read your mind? I can't experience what you're experiencing. I only experience what I'm experiencing.
Yeah. So the idea is that, so there is this universal field of consciousness. There is this field of matter. The field of matter, whenever Big Bang happened, it started slowly moving, started organizing. First set of organization was galaxies. Then we had, stars and stuff like that. Then slowly, this field of matter came to be organized in the form of a human body with certain neuronal, organization. So the idea is that there is some kind of interaction which happens between the universal field of consciousness and the physical system, which leads to this creation of the mind and the, prana, the other sheets which I spoke about at the beginning. And what is me as an experience of Kushal Shah and what is your experience as Catherine is that mind thing. So this individual thing that we're experiencing is not the universal consciousness, but the mind which is individual. So my
So
mind is individual.
are you calling yourself a dualist by saying there's the field of matter and the field of consciousness and they
Yes,
interact? Okay.
yes.
Because there are, it's very popular now to argue for the idealist viewpoint, and that there is only a mental phenomena, and that essentially, I guess you would then say that matter supervenes on mind in that sense. And the idea,
Yeah.
but whether you're a dualist or an idealist, I think the idea of our experience as a user interface to the physical world is an intriguing one. And you can think of it as your computer desktop. I think the analogy, and if I click on a file that a box that has a W on it, it's a Word file, and I drag it over and drop it into a thing that looks like a trash can, I'm not actually moving a box to a trash can. There's a whole bunch of things that are going on in my computer that correspond to that image, but what I experience is the phenomenon of dragging something to a trash can, and we can kind of make that analogy of our experience of the physical world. And I think that's compatible with both dualism and
Yes.
idealism. that view
Right.
of us as experiencing a user interface.
Can
Yes, and precisely
uh,
because of quantum mechanics, because there are all these wave functions and stuff, and what we experience is anyways like a a snapshot of what is going on at the fundamental level. So yeah,
Hmm.
yeah, right.
Gustav, you
Uh,
were talking.
good stuff, yeah.
now I was just suggesting that could we wait a little bit to the end of the talk to have a more extensive discussion.
Oh, sure.
Yeah,
I thought he had asked for comments throughout, but yeah, we can wait.
Oh, okay.
no problem, no problem. Thank you. So yeah. So the idea is that as I mentioned, these are not proofs of any kind, but these are certain directions which I'm taking for reasons which I've specified. So again, this option 2 is something which is very very popular, but I think anesthesia is a very strong experimental evidence by which the idea of an individual consciousness can be ruled out. This is something I believe has not really been studied, in lot of depth. But this is the direction that I wish to take, and in the coming months, I would like to actually, work with people to come up with something very concrete to show that how the experience of blackout during anesthesia can be used to completely rule out the idea of an individual consciousness. I think that is something that can be done, which I'm going to, pursue over the next few months. So the idea is that, as Catherine nicely explained, that I am basically proposing a dualist kind of a framework where you have what is called a physical reality, and you have something called a unified field of consciousness, and there is some kind of an interaction that happens between these two realms. So the final synthesis is that, as we show in the paper, which I'm going to talk about very soon, is that conscious macrostates do not supervene on physical microstates. Uh, Causal closure of the physical is violated in conscious systems, which is sort of, part of, quantum mechanics also, again, as Catherine mentioned. But again, the issue is that when you look at quantum mechanics, people have tried to come up with the idea of decoherence and multiple worlds, and try to do away with the requirement of consciousness systems. But we very categorically say that, in conscious systems, this causal closure is violated, immaterial of whether you believe in decoherence or the Schrodinger's picture, or whatever. Because of this, conservation of physical energy is violated in conscious systems, and the individual persistent self is a temporary sensation which happens because our physical body, which has taken this form, is interacting with the universal consciousness. So we have a sensation of being a separate entity with a separate set of desires, purpose, and so on. But that's a temporary sensation that sort of dies when we die. So consciousness is basically a unified, fundamental, non-physical property, which is of course not something that I am saying for the first time. Many people have said this many times, but this is something that I'm trying to emphasize upon, and something that hopefully can be proven in the coming months. So where does that leave us with the hard problem of consciousness? Does it mean that the hard problem of consciousness has been solved or something like that? Of course not. So what I'm again proposing is a certain direction that one should take to solve the hard problem of consciousness. So the question that, of course, is at the core of this, branch of study is, why does neural activity lead to, subjective experience? So the answer that we are proposing is that consciousness is a physical property of nature, and certain patterns of physical universe can couple with this fundamental property. So this is what we are proposing. Then the next question that somebody will ask is, can we find these neural correlates of consciousness? The answer is yes, of course. Neuroscience will find them eventually. They have already made a lot of progress in that. But the issue is that these patterns are neither necessary nor sufficient. This is something that I would like to emphasize on a lot, that even if, let's say, even if after 20 more years of rigorous research, even if neuroscientists are able to find these neural correlates of consciousness that will not solve the problem, because these patterns will neither be sufficient nor necessary, and there are possibly infinite number of such patterns which are possible. There are many different biological organisms, many of which have conscious experience, and there is no reason to believe that they all are using the same neural patterns as we are using. That's not possible actually, because their neural architecture itself is often quite different from the architecture of human beings. So what exactly does it mean to solve the hard problem of consciousness from this perspective? What it means to solve this problem is to do two things. One is to find concrete evidence for violation of energy conservation. Currently, we have a theorem, we have some ideas, but we don't really have very concrete evidence to nail this down. That is something that we need to find. And although we have a no supervenience theorem where we show that conscious macrostates do not supervene on physical microstates, but that's under very specific conditions, the idea is to further improve and generalize the theorem. So these are the two things that we really need to do to solve the hard problem. And how will the hard problem get solved? Because once we have done these two things very well, it naturally follows that consciousness is a separate layer. It does not emerge, it does not supervene on physical microstates. That would be established fairly rigorously, and neural correlates of consciousness would then become a matter of detail and not something that is really really important, because as I just mentioned, that these patterns can be many. It's not like just one single pattern that leads to our conscious experience. So the direction that I have been taking for the last few years is to sort of find concrete evidence for this for violation of energy conservation. Not so much success so far, but I am hoping that I'll succeed in the near future. So now coming to the actual paper that we published, which is the main topic of this talk, is so this was co-authored by Catherine Reason, who is a London-based person with whom I interacted through a Google group. So both of us had this idea that that there is violation of energy conservation in conscious systems. I came from my Indian perspective, and she came from her mathematical background, and we sort of came together, and we found that our ideas were sort of similar. So we came together to combine them to write this paper, which got published in JCS in 2021. And I must mention that this is kind of an informal proof. It is still not in the form of a rigorous mathematical proof, and we are working towards making it as rigorous as we can. Any help from this group would of course be much appreciated. So what we have is a kind of a no-go theorem. You may already know what it is, but just for the sake of clarity. So a no-go theorem is basically a statement that proves that a particular situation or a theory is physically impossible, but only under a specific set of assumptions. So the approach that we are taking is to sort of prove a no-go theorem. So we'll take a certain theory, which is popular in physics, which is that conscious macrostates supervene on physical microstates. Physics believes that, and we are going to show, and we have actually shown that this is physically impossible, however, under a specific set of assumptions. So this is not a dead end for this idea, but a stop sign, something that physicists need to take note of. And again, as I mentioned, ours is an informal proof. It is not still a completely formal proof, because our proof is again in the form of English statements. We have not really formalized our proof so far. That is something that is work in progress, and we hope to reach there sometime soon. So the basic idea, before getting into any kind of mathematical detail, the basic idea is that which is something that is actually well known in philosophical circles, that inherently subjective being can never establish the objectivity of anything, and let alone the objective of an inherently subjective phenomena. So this is something that is not much appreciated, although people are aware of this. but it is not as much appreciated, as it should. That beings like us who are inherently subjective, everything that we experience is through our consciousness. Strictly speaking, we can actually never establish the objectivity of anything, let alone the objectivity of something which is inherently subjective. So now coming to the actual proof, as I mentioned, ours is a no-go theorem. So it is of course based under certain specific assumptions. So we are talking about a system which has three main properties. What are the three main properties? The first property is that the system must be capable of self-certainty. Self-certainty means I should be able to perform a function which I am calling the self-certainty function, that I am certain about something. That is a self-certainty function which I am performing. The second assumption is that the system that I am talking about is capable of human-like reasoning. So I, as a human being, I am a logical human being and I am capable of performing human-like reasoning. So we are talking of a system which has this property. The third property is that the system must be physical, that it must be verifiable by multiple observers. This is the definition that we are giving to something which is physical, that something which cannot be verified by multiple observers, that inherently becomes subjective. But if something can be verified by multiple observers, that becomes physical. So what we will do is that when we take a system which has these three properties, we will see that we are led into a serious problem and there is no escape from that. And because of that, the natural conclusion will be that a system cannot have all the three properties simultaneously. So if the system is capable of self-certainty and it is also capable of human-like reasoning, then it cannot be physical. So this is the basic conclusion that we derive from our work, that systems like humans which can perform self-certainty, which are capable of human-like reasoning, they cannot be physical. That is the basic conclusion idea. So the basic sort of idea, I will not be able to get into a lot of details today, but if somebody is interested, I'll be happy to get on a call sometime later to have a more detailed discussion about our proof. But today I'm going to share the basic premise of the proof, and then later we can get into the details for those who are interested. So the idea is that I am sort of constructing a function, omega, which is 1 if for some value of time t, the actual state of s of t is not null. And when I'm saying that the actual state of s of t is not null, that is when I am performing the self-certainty function. So at times when I'm certain of myself, those are the times when this self-certainty function is being performed by some process within me. Now the thing is that performing a self-certainty function is not a problem, that is fine, but the challenge is how do we establish that this process that is being performed by processes which are themselves which are physical. So if my omega is something which is purely physical, then there must be a set of processes which are needed to perform the self-certainty function, and there must be a set of function which is this chi, which is 1 if the processes in X are physically real, and if they are not physically real, then they must be undefined. Now the challenge over here is how do we establish that the processes in X are physically real? To do this, we need another set of process to check that these processes are physically real. So to check that omega was physically real, we needed some other set of processes. Now to check that these processes are physically real, we will need another set of processes. We can call it chi prime. Now to check that chi prime is consisting of a set of physical processes, we will need another set of processes called chi double prime, and so on. So this leads to an infinite regress, and that is the problem with this idea, that human beings can perform the self-certainty function which we are calling omega. So performing omega is not a problem, but the moment you want to establish that omega is performed by a set of physical processes, that leads you to an infinite regress, and there doesn't seem to be any escape from this thing. So unfortunately, I'm not able to get into all the details of this theorem, but I can take it up later. Today, I wanted to spend more time on the motivation of all this idea because I thought that was something which was more important. So the idea is that a purely physical system cannot perform the self-certainty function, but we know that human beings perform the self-certainty function. So the only obvious conclusion from here is that physical human beings are not purely measurable, and so human systems must violate conservation of energy in some way. What way is that, we still don't know. But the conclusion from this theorem is that the human systems must violate it in some form. And this is still an informal proof. We are working to make it formal, but that is work in progress. Hope to reach it, sometime soon. So again, so we are not claiming that all of physics is wrong. Of course not. We are just claiming that the laws of physics can be violated under certain circumstances, and in particular by conscious systems. Again, this idea is not something new. Robert Rosen in the 70s and the 80s spoke about it quite a lot, and his ideas have been very influential. What we would like to do is look at it from a more physics perspective and a more mathematical perspective, and try to see if we can establish that on more rigorous mathematical footing. So that is the end of my talk. Thank you everybody for the kind attention.